In this video, we'll do performance analysis on new or existing ABAP code. There's two types of performance analysis that we will execute. First one is just analyzing the ABAP code, profiling the ABAP code. Second one is analyzing the database access and looking at the execution plan of SQL statements that are being executed. To do this, we will use the flight data model that is part of every SAP system as a test data model for all kinds of experimentation. It's a very simple data model. It contains a flight master data table that contains information about flights, where they start from, where they go to, what their price is, and the capacity. Then we have a flight plan table where we have the ID and the date that the flight leaves on with a number of occupants in the airplane. We have information about the flight attendants, the pilot, co-pilot, and the 4 attendants. And then we have booking information, which contains information about what person sits in each seat on that particular plane. We created two reports, one to create data in the flight tables, which is the one you see here. It creates random data for flights and bookings in those tables. To fill the tables, you can enter a number of flights per day and a number of days and then execute it, and that will fill those tables. The second report is the passenger information report. It will show us all the information about each passenger, what the total price they paid is, what the total price they would have paid without any discounts would be, and how many flights they took. So it's just a report that we wrote to be able to analyze performance. So the content of the report is not that important, but you can download the full source code from the GitHub repository that is mentioned at the start of the video. For ABAP profiling or performance analysis, we use the transaction SAT, and in that transaction we can analyze the performance of an existing SAP report. In this transaction, you can analyze transactions, programs, or function modules, or you can switch on the performance trace for a session that is already running. We'll use a program here and do a performance analysis. First, however, we're going to create a variant that tells us exactly what it is we want to analyze. So we'll put in a variant name, click create, and then we're going to define what we want to analyze. Now, most of it is already checked, but the important thing is that we also check the read operations and change operation for internal tables, because that's usually where we need the most information from our ABAP code. So we can save this variant and go back, and then we can execute this report. Now at the bottom you see determine names of internal tables. That's really interesting, because then in the performance analysis you will see the actual names of internal tables. In older versions of SAP that was not available, and it would just be internal table 1, internal table 2, etc. So select that and then hit the execute button to execute the report. So then the report will be executed while the performance analysis is running. Once the analysis is complete, we can go back until we end up back in the SE30 transaction or SAT transaction, where we will see the performance analysis results. On the left hand side, we'll see a high level overview, where here we can see that a lot of time was taken by the internal tables, 82% of the analysis, and the data access external, data access internal, basically the database access was a lot less. More information we can get from the hit list. The hit list contains information about each part of the code that was executed and how long it took. It's automatically sorted by net percentage descending, so the statements that took the most time are always directly at the top, so you can very easily pinpoint them. In this case, the read on our internal table with the flight master data was the read that took the most time. So you can see also that the database access to the flight booking table took about 70% of the time. While a specific record is selected, we can click on the display source code button to go into the source code and see exactly where that statement is. In this case, we see a read on that table. For we click on the table, we can already kind of guess why this takes so much time, because this table is a standard table without any sorting, and we're doing a normal read on it. So every time we do this statement, ABAP has to navigate through all the entries in that table to figure out which one we want to see. So we can see percentage of time it took, gross net, and also the number of hits. So in this case, we executed that statement 1,300,000 times. So that's the ABAP performance. We can also have a look at the accesses to the database tables. This is just giving us a time, how long it took to execute a specific statement, or all the statements on a specific table. So in total for the flight booking table, 1.3 seconds. We see a lot of other tables there that we didn't really select. That is internal SAP ABAP stuff, tables that were also being hit, but not specifically by our own code. So the flight booking table is the table that we spent the most time, or the database engine spent the most time on. I already mentioned that there's also an SE30 transaction, an older one, which is basically the same transaction, but it has an additional summary view that can give us some useful information. When we hit the evaluate button here, we see a summary overview before we see the details, where we see how much time was taken on the ABAP code, how much time was taken on the database, and how much time was taken up by the system. The summary view is not there in the more modern SAT transaction. Again, here in SE30, you can go to the details just as you can in SAT, but it looks a little bit different, and it also doesn't show you the internal table names as it did in the SAT transaction. So here, for example, we'll see when we sort it, we see read table IT 39, internal table 39. So that is not so easy to know which table that is. We can drill down to the source code to see what it is, but it's still easier in the new SAT transaction. So far, we looked at the ABAP trace profiling. Now we're going to look at the database trace. We go to transaction ST05 and activate that with filter. The filter in this case would be our username, and we could also put in a report name, so we make sure that no other activity happening with that same user is being used in our trace. We could also limit by table names. Let's not do that for now, but if you only want to trace for a specific table, you can do that as well. With the trace activated, we execute our report. And when the report is executed, we can stop the trace and display it. When you hit display trace right after you stopped it, it will automatically fill in the trace period with the start and end of the previous trace that you executed. But you can of course change that. Then we execute that. In the trace, we'll see all the database statements that were executed on all the tables and how long they took. From here, we also have the ability to show the execution trace or execution plan for the database statement. Unfortunately, the system that I was doing the demonstration in so far is a SI-based system, and on a SI-based system, you cannot actually see the execution trace. So we'll do the same thing on an Oracle system and on a Hana database system to see what the execution plan looks like. On a Hana database system, the trace looks pretty much the same, but we do have the ability to have an explain on each SQL statement. So we select the statement here, and then we hit the explain button. Here we'll see the explanation or the execution plan of the database statement. Since it's a column database, you'll first see a column search, then a column table access. Now, this is very summarized. It's not very detailed at all. So what you can do is hit the execution trace button there at the top and download the execution plan. Save that PLV file so we can later open it in our HANA Database Studio. Drag the PLV file that we just created onto your HANA Database Studio, and the execution plan will open there. In the first view, we'll see an overview of how long it took for each step of the process to be executed. We click on Executed Plan, we get some more details. First, we see just a summary, an overview of what happened, the column search. We can expand that to see what steps were taken to get to that result. And each step we can keep expanding until we get to the eventual detail. So in this case, there was an acquirer of the log, a search without filter on the table, and then the results were materialized, and that resulted in 1.6 million rows. Now, most likely in real life, these plans will be a lot more complex, but this is the way to get to them and to get all the details about database statements executed on a HANA database system. Now, this is what the database trace in an Oracle database system looks like. So again, we can see similar results. We see here that we had a 5-second select for 426,000 records. Here we see the select statement, and here again we can display the execution plan for this statement. So we can see that the execution plan here used a full table access. So that means that no indexes were used, nothing was used, and this is the estimated cost. Now if we look at another statement, here on the flight M table, where we had an order by, we can see that there was an actual index scan on the first index. So the index number 0 is always the primary key, and then after that we did a table access by row ID based on what we found in this index. You can get more information on the index by clicking there. See that there's only one column in this index. I get some more information about the select, but here you can see how the table was accessed. So if you see some selects with a high estimated cost, high input-output cost or high CPU cost that are not using an index, then perhaps you can either reconstruct your select statement or try to get an index added to the database table to optimize the select.